Okay, so let me share my screen really quick, and you can see my slides here. I'm going to talk about machine learning for .NET developers. You had an opportunity to actually learn a little bit about ML.NET yesterday. I know there was a great session by ML.NET team, Louis and Bree did really amazing job. So if you had a chance to check out the session, awesome. If not, I'm sure you'll be able to see it in recording. But I hope my session will actually help you to create and have that bigger picture about machine learning and especially ML.NET. So let's move forward. And okay, next slide. Yeah. Here are some facts about me. Again, my name is Veronica Kolesnikova. I'm 3 times Microsoft MVP in AI. I'm currently working as a senior software engineer in Boston, Massachusetts. I have a master's degree in information technology. I started my career as a quality assurance engineer and then moved to development. I used to work mostly with Microsoft technologies like C Sharp, .NET. I obviously love machine learning, artificial intelligence, everything related to that. I also like Xamarin cross-platform solutions. I am playing a little bit with Maui just for myself to learn a little more about it. But recently, I also started working more with Java and Node.js. And my hobbies are dancing, traveling, and aerial yoga. Okay, so now you know a little more about me, and I want us to focus on ML.NET. So ML.NET actually is perfect for us .NET developers. When I first learned about ML.NET, I was so happy that I didn't need to learn any additional languages like Python and R. I actually learned them anyways, but there are always some challenges with that since I don't use them on a daily basis. It might be a little tricky to switch back and forth for me. So it's really convenient for us .NET developers who use C Sharp and F Sharp every day to integrate ML.NET and add that machine learning functionality, all the capabilities to all kinds of applications, no matter what kind of application you are building, whether it's a console application, web application, mobile application. Again, going back to yesterday's session, Louis and Bree, they showed a great example of how ML.NET can work with Maui application. So again, check it out if you have a chance. And actually, ML.NET offers lots of scenarios such as sentiment analysis, issue classification, forecasting. I show just a couple of them right here. Probably those are the most popular ones, but actually there are way more scenarios available. So if you are trying to integrate some machine learning into your existing applications, or you are building new applications in that machine learning functionality in mind, then definitely take a look at ML.NET. It's all open source. So here I have a link to GitHub where you can see the code, you can submit issues, and all those open source benefits are there. Also, I keep telling people that actually Microsoft documentation is great, and I am not just saying that. There are good examples, really detailed, step by step step-by-step instructions how you can actually set up your first application, or maybe if it's not your first application, you're just trying to learn a little more, add some capabilities, then it is all documented there. Also, they have on if you go to that GitHub repo, you can also have a link to samples, and also to you'll be able to see future plans, what is in the pipeline, what's happening with ML.NET. So it's really useful. I definitely recommend check out the repo. Now let's move to AutoML and ML.NET Model Builder. I want to talk a little bit about that theoretical part of all of it. AutoML is actually not specific to Microsoft technologies. It is just basically a really cool way for machine learning developers. It's not just a way, it actually entails a bunch of tools that are having AutoML behind the scene. All those tools and techniques, they are helping us developers or data scientists or whoever is trying to create a machine learning model. They are helping to save time, actually doing all the lengthy, complex work for us, and it is really cool. Um, AutoML covers the complete pipeline from the raw data set to the deployable machine learning model. And I think the cool part there is that you don't have to choose correct model type for your data. Usually it takes a while, or if you're a data scientist, then you need to have that experience so you can understand what model type is better and what can be more efficient. So usually, as I said before, it's a lengthy process, takes lots of time, can take lots of resources. So it's really cool that AutoML can save time and save resources. And I'm really happy that Model Builder uses AutoML. Model Builder is actually available in Visual Studio, and I'm going to show you a demo which include the model builder. But if you are not a fan of all those buttons and extensions, and actually it's not an extension anymore, it comes with Visual Studio. So when you are installing Visual Studio 2022, you can just check that ML.NET model builder and it will be installed automatically. Um, but if you don't like that, if you prefer CLI, then it is you have a CLI option as well. So you don't have to have it in your Visual Studio. You don't have to go through use the UI to actually access the model builder. Model builder includes some scenarios that are available for ML.NET. And those scenarios are text classification, value prediction, image classification, recommendation, and object detection. And also a couple of limited scenarios there. Um, you'll see that there are good examples of how to use limited scenarios, but they are limited. So I definitely don't recommend using them in production or in real um, real solutions, but it's just good to learn about them and see what is coming next. And now let's move to a demo. Let me switch my screen. And here, I hope you can see my Visual Studio 2022. I installed it just a couple of days ago. I know I'm crazy. I usually don't do stuff like that. No, that's the rule of presentation. When you have a demo, you should just leave all the updates for a couple of days just to make sure everything is working. But I think I trust Visual Studio 2022, so I installed the GA version. I used preview before. I am really happy with it. So that was a little pitch about Visual Studio 2022, but let's go back and create a new project here. I'm gonna just create a console application from scratch, and then I'll add machine learning capabilities using ML.NET Model Builder there. So it's a console application. I am using C Sharp. You can use F Sharp as well. I am gonna just leave it as console app 2. You definitely, if you are building real application, and it's just a good idea to update their name so you remember what's happening. But just for the demo purposes, I'm gonna leave it like that. And here you can see all the frameworks that are available, and .NET 6 is available, which is super exciting. And ML.NET is supporting .NET 6. So we'll use that. And I'll just create console application, which will be completely empty. And then I'll add a machine learning model using the model builder. It takes some time to create a project. Visual Studio is thinking, but I am believing in the Visual Studio. So let's give it a second or two, and hopefully it will create a project. But what I want to mention is that you don't need to have any knowledge in data science or background in machine learning. You can just open the samples, see how ML.NET works. It is really useful to understand how it works and what is happening behind the scene, but you don't need to have special education for that, especially when you are using Automl. It's gonna be just pretty straightforward. Let me see what's happening here. Let me actually cancel. Okay, and just restart Visual Studio. Okay, so yeah, it created it. Just opened in a different screen. Let me show you what's happening here. So it is completely empty console application. What you need to do here to add that machine learning capabilities, I already have ML.NET Model Builder installed, so I don't need to check anything. But if for some reason you don't have that add machine learning model option here, please check that you have ML.NET Model Builder installed. So you click on that. It loads some templates. You can update the name here. I'm just going to leave it like that right now. And then we'll see the model builder screen. Let me actually close that. And you'll see all the scenarios, that data classification, value prediction, and then the scenarios that I mentioned, and including actually 3 limited scenarios right there with examples and links to documentation. So that's really convenient. You can see that for some scenarios, you have only local option. For others, you have Azure and local. why you might need to think about Azure option, especially for those heavy scenarios like image classification and object detection. When you have lots of heavy data, and by heavy data, I mean high quality images, you have lots of them. They are consuming um, a lot of the a lot of memory on your computer. Maybe you don't have enough, and you don't have to have it because you have all the benefits of cloud. So you can connect it to Azure. And as you know, Azure has pretty much unlimited capabilities there, lots of data storage, lots of processing power. So definitely think about that option when you are using more data heavy scenarios. But today I will choose the data classification scenario here. This scenario is actually um, the most, I think, straightforward. And actually, the training process is the fastest for that scenario because you don't have that heavy data, as I mentioned before. You don't have images or videos, it's just text information. That's why that scenario is perfect for quick demos. And that's why I'm choosing it today. So you can see local CPU environment. Um, there is also a new option, the local GPU. You need additional setup for that. And actually for this specific scenario, Azure and local GPU options are not available. But if you are using other scenarios like image classification, then you'll have those two options available as well. So we'll move to next step, and here you have two options. You can either use data from a file, it can be CSV, TSV, or TXT file, or you can connect to a SQL Server. I'm gonna use a file today, and it's a pretty straightforward data set, which I actually got from one of the samples from that ML.NET um, GitHub repo that I mentioned before. So just loading the data here. And a really cool thing is that data preview part that you can actually see what kind of data you have. You're not going to see all the data, especially if you have bigger data set. But it's just really nice to see what columns you have. Maybe you need to filter them out. Maybe you need to exclude some of them. So here you have that advanced data options where you can maybe ignore some columns that are not related, and also um, use other formatting. I don't recommend using that advanced data options if you need to filter data or your data is not 100% prepared and you want to pre-process data. When you need to remember when you are loading your data set here, it has to be clean. It has to be ready for training. And there are so many tools that can help you to actually prepare your data, clean it out, maybe remove information which is irrelevant, remove empty rows and columns. So definitely make sure that your data is prepared and ready. But here I have the demo data set, which is nice and clean, and I made sure that it didn't have anything which is not usable for machine learning. So we are going to predict the sentiment column here. So based on the sentiment text, we'll predict sentiment, and 1 means it's root comment, and 0 means it is not a root comment. And here we need to train our model. Um, there is a really useful link. You can click on it and you can learn more about timing, because the timing option here is editable. You can change time, add more time, add less time, or you can actually agree with whatever was offered. So they are offering 10 seconds, and I'm gonna use 10 seconds training here. So if you open the output here, it went actually really quick. 10 seconds goes really fast. You see that it went through that type of model. And then it spent so many seconds to actually analyze the type. If you add more time there, then it will go through more model types and maybe pick a better one. But since it didn't have enough time here, then it chose this model for your data. The accuracy, 62%, is pretty low right here. So I definitely don't recommend using that model in production or anywhere outside your demos. Usually it is 80% and up for some scenarios. Obviously, the closer to 100%, the better, especially mission critical scenarios, maybe when you're using it in IoT solutions or medical related solutions where it is really important to have high accuracy. But here I'm gonna just leave it like that. And there are a couple of options how you can improve here. So first of all, you can add more time. Second, you can add more data and then retrain it. So it will provide better accuracy. And here, there is an option to actually test your model, evaluate and see if it's working correctly, if everything went well, and it can predict. So by default, it's actually grabbing the top sentiment text. That was just the top row from your data set. What data scientists usually do, they have a bigger data set, so they split it into two parts. One they're using for training, and the second part they're using for evaluation. It's really important to actually evaluate your model with data that wasn't used for training. It is just making sure that the model is working correctly using unfamiliar data there. But since I didn't do that and I have really small data set, I'm gonna just click predict here. And it is 50-50. So first of all, the accuracy is pretty low. The second is the data set is pretty small. But when you are building real life applications, you can and you get result like that, then that means you actually need to go back and retrain your model. So that model shouldn't be usable for production scenarios. But for demo purposes, I think it is good enough. Next step, you can actually just grab code from here and add it to your application. Or if you want to see how it actually works, how it's connected, um, then you can add a console application or web API right into your solution. So I'm going to do that. There's an option to update the name. And here you can see you are getting that test console application, which is connected to your model. The model itself is actually right here, that ML model1.zip. That's the model. You can move it around. And it is also right here. You have the training part and then consumption part that you can use. But I am going to open so when you go to next step, I don't want to miss that part, but you have an option to learn more about deployment and your model improvement. But we are done with the model builder, and here we can see how it is being used. So we are passing the text. So this text is supposed to be dynamic, but for those demo purposes for testing, it is already pre-filled for you. And then you are getting all the information from the model. So you are using that predict method with sample data, and sample data is here. And then you are receiving sentiment back, your prediction. So let me actually run it to see that it actually works. And it is open in the different screen. So here you can see that we passed that text, and the predicted sentiment is actually 1. So that comment is root, and actually it is root in the data set. So it predicted it correctly. You can see how it is the model being used here. Also, it is very important to see those training files that are offered here. You see that the library is used, that Microsoft ML, that is ML.NET. You see how the model was created. So next time, maybe if you don't want to use the model builder and want to create everything from scratch using only ML.NET, you can see how it was built, and then try it yourself next time. You see, we got the data set and then appended all the columns that were needed. And then, we trained using feed method here. And then the consumption is used for model consumption. We have the predict method, where we get in the predict engine, and then using it, we are predicting the response. In this scenario, it's sentiment that we are predicting. But if you're using other types of models, other types of data, you'll also have your model and then those files, and you'll also see a sample console application or web API that you can check out and see how it all works. So that is pretty much it. I just want to mention one more thing that actually ML.NET team asked me to pass to you. ML.NET Hackathon will be tomorrow, actually. It is super fun. I checked what they did last year. They did an amazing job with ML.NET. So if you have any experience with ML.NET or you don't have any experience, that's totally fine. It's a great opportunity to learn more, to be connected with experts, with the community. So definitely check it out. It's going to be tomorrow. And that's it. I am ready for some questions if we have any.
Thank you so much. I am not seeing any of the questions that I'm seeing in the .NET Conf feed live pop up in the little list of questions here. So I'm going to hop over to this Twitter window that I'm not going to share right now. And I'm going to read some of these to you. My apologies. We've got one from Hamed. Can we replace the object detection model in the TensorFlow host with the ML.NET host? That was the first question that I saw.
Okay, that's a tricky question. I'm not sure if I understand it correctly, but ML.NET can be used to consume not only ML.NET models that were created either using just straight ML.NET or the model builder, but you can use ML.NET to consume Onyx models and also TensorFlow.
Okay,
So you don't have to have ML.NET model in order to use ML.NET.
got it. Okay. And then David asked one more question that I think is similar. He said he recently used the object detection model in TensorFlow. Can he replace in TensorFlow serving? Can he replace it with ML.NET hosting? I don't know if that's similar.
Yeah, so I'm not 100% sure what they mean by hosting. So maybe if those people can reach out to me directly after, we will talk more about it, and I'll make sure that I understand what
Okay.
the question is. But yeah, in general, ML.NET used with Onyx and TensorFlow models.
Good to know. Well, Hamed and let me see again, David, we would encourage you to reach out directly to Veronica on Twitter if you have that question. And then we could get you an answer to it. And then y'all could collaborate a little bit on that. But with that said, I want to thank you for a great presentation on machine learning with .NET.